STA408 stands for Statistics for Sciences and Engineering. Okay, so first of all, I would like to explain on tentative scheme of work. Okay, tentative scheme of work. Okay, so right now we have 31 of you who have joined this session online. So actually, total number of students that should be here today is 28 from 5D and 26 from 5C. So altogether would be 54. Okay, 54. Okay, I don't know what happened to the rest of the students, but we can just start now. Then after the first session, I will share the recorded video to all of the students. Okay, first I will explain on the tentative scheme of work. Okay, let me share the screen. Okay, can you see my screen here?
Yes.
Yes, doctor.
Right. Okay, so actually for STA408, there are 5 topics altogether that will be covered. Okay, so 5 topics start from probability distribution. Okay, probability distribution. So here we will cover discrete and continuous probability distribution. So ada dua. So for discrete probability distribution, actually there are a lot of distribution that can be covered. But for your course, we will only concentrate on binomial and Poisson distribution. So ada dua je. Under discrete probability distribution, so we will cover only 2 type of distribution. And then under continuous distribution, only 1 distribution will be covered for this course. Okay, but in real life, actually we have a lot more distributions. Sebenarnya ada banyak ya. Okay, and then for topic 2, okay, for topic 2, entitled estimation. So here, untuk estimation, we will cover the sampling distribution, point estimation for mean and variance, interval estimation. Okay, so all of these calculation involve actually each of the chapter, each of the topic here involve a lot of calculation. Okay, so a lot of calculation. So you will need to have calculator. Okay, every class. Okay, every session. You have to have a calculator with you and also statistical tables. Okay, statistical tables here. Okay, so you can print out the statistical tables here for your reference, and also a set of formula. So this is a set of formula that will also be given during the final assessment. Okay, final assessment pun akan diberikan the same set of formula. So you have to familiarize yourself by using the same formula. Then it will help you with your problem solving lah. Okay, so for interval estimation, okay, for the second topic here, we will cover the interval estimation, in which you will be asked to compute the confidence interval. Okay, confidence interval using normal distribution and Z distribution and also T distribution. Okay, when to use here, you have to know when to use the formula, because the formula is already given to you. but you, based on the question, you have to know how to use the formula and which formula should you use. Okay, should you use Z distribution or T distribution? So here, in order to help you with this topic, you during the lecture session, okay, you have to jot down important information when to use and when not to use. Okay, so as long as you understand the concept, actually it will help you with the course lah. Okay, okay, and then next is topic 3. So in topic 3, we will cover hypothesis testing. So we start this topic after mid semester break, which is after Hari Raya Aidilfitri lah. Okay. If you refer to this color, the green color here, it means that you will be given the first assessment before the break, before the mid semester break. Okay, so this assessment will cover topic 1. Okay, we'll cover topic 1 and also probability for sample mean here. Okay, so this involve 8%. Okay, 8% of the total assessment. Okay, so we call this as assessment 1. So assessment 1 here involve 2 parts, which is to cover for quiz 1 and also test actually. Okay, so ini sebenarnya quiz 1 and test ni is from the original syllabus. Original syllabus. But since we are conducting the class using online session, so we just combine quiz and test. So altogether, it contribute to 8% of your assessment, total assessment. Okay, you can interrupt me if you have any question. Boleh interrupt. Okay, and then topic 3 after mid semester break. And then for topic 3, we will cover the hypothesis testing. Okay, here we will deal a lot with testing the hypothesis. Okay, based on 1 population mean, 2 population means, 1 population variance and 2 population variances. Okay, itu yang kita akan cover lah. And then after that, okay, for topic 3, there will be the second assessment. Okay, but here the second assessment involve topic 2. Okay, all topic 2 exclude the probability for sample mean. Okay, so this contribute to 13% of the total assessment. 13. And then special break here, and then week 9. Okay, week 10 we will cover topic 4. So topic 4 ni at week 10. Okay, so for topic 4, the things that we will cover is on the introduction to experimental design. Okay, one-way analysis ANOVA, which is ANOVA. Okay, one-way analysis of variance and also two-way analysis of variance. Okay, ini topic 4. Okay, so it's about 2 weeks. Okay, to cover all the topics here. And the last one is topic 5. So topic 5 ni regression and correlation. Okay, so here we will cover simple linear regression, only for simple linear regression. Okay, and also correlation analysis lah. Okay, for 2 weeks here up to week 13. Okay, and then week 14 revision. That's all. And then the final assessment will be given tentative date here is 23rd of July. So week 16, on week 16. Okay. Any question here?
No, so far so good.
So far so good.
Right. Okay. So if you have any question with regard to tentative scheme of work, anytime you can just ask in the group lah. Okay, Telegram group. Okay, so our communication will be using for communication we'll be using the Telegram group and also online session lah. Okay, for the online session. All right. If you have no question, then we just start. Okay, it's the first topic first. Okay, so this is a topic 1 about the probability distribution. So as I mentioned earlier, the subtopic that will be covered here is about spatial discrete probability distribution, which means that discrete. Okay, so for discrete we have two type of distribution, which is binomial and also Poisson distribution here. Then next is continuous probability distribution. I need to check. Okay. No more requests from your friends. Okay, so for statistics, actually there are a few terms that you need to know. Okay, so what is meant by statistics? Okay, so a few statistical terms that are very popularly used in this course. Okay, population, sample, parameter, random sample, random variable, and so on here. So ini adalah some of the statistical terms that will be used throughout the discourse. Okay, so have you ever heard about population and sample before? The term here, random sample, pernah dengar?
Tak.
Okay. Alright. It's okay if you have never heard about these terms. It's okay. We will cover this part as long as we go through the topic. Okay, population, sample. Okay, so actually population is a group. Okay, is a group of phenomena or people or objects. Okay, or events or procedures that have something in common. Okay, so unlike sample, sample ni is a smaller group. Okay, part or subset of the population is a sample. Okay, so let's say we are talking about all Malaysian. Sorry. Okay. Okay, all Malaysians who play internet game at least once in the past years. Meaning that we are talking about a group of people here. Okay, so a group of people from this sentence, you find out what is the point to cover a group of phenomena, a group of people, or a group of objects, and anything here. So all Malaysians, so which means that this sentence represents the population. Okay, and then a 500 Malaysian who played internet game at least once in the past years using the same criteria, but we only take out 500 Malaysian from the total here. So this represents the sample, okay, which is a smaller group of members of a population. Okay, smaller group of members of a population. Kita ambil sample from that particular population. So that is a sample. Okay, part of the population. Okay, so second example here, all daily maximum temperatures in September. Okay, in September for Selangor. So all daily maximum temperatures. Maksudnya, it means that this is a group of phenomena. So which is represent the population. Okay, population. All registered CS 241 students, like say CS 241. All registered CS241 students in UiTM. Okay, a 200 registered CS241 student in UiTM. So which means that the first sentence here represent the population and then the second here represent the sample. Okay, meaning that sample ni part of the population. Alright. So if you want to know more on this, you can just click the link here. Boleh tengok lah. Okay, so why we need sample? Okay, why we need sample? Because if you want to analyze something, okay, you have to have a data. Okay, so you have to have a data. However, if you refer to population, it's not easy to find all the numbers based on population. Okay, if we are talking about a population of 1,000 number of students or 10,000 number of students. Contohnya population tu ada 10,000 number of students. But if you want to find out, if you want to conduct a survey for all the 10,000 number of students, it's not that easy because it involves a lot of time, okay, time consuming. You have to consider about financial part and everything here. So actually it's not easy to conduct an analysis based on population. That's why we need a sample to help us, okay, to help us with the analysis. Okay, but in order to find a good sample, you have to refer to how many samples do we need, how many samples do we need to consider. If the population is about this much. Okay, so kalau 10,000, so how many sample is the most appropriate number? So itu kena kira lah. Okay, why do we need to consider that? Because to be able to make a good inference on the population, we need to have a good number of sample. Okay, sebab apa? Sebab based on that sample, you nak buat the same analysis, tapi you guna sample. So based on that sample, you want to find out apa keputusan based on your analysis tu. So you must make sure that everything that you did must be appropriately conducted. Daripada sample size and so on. Because at the end, you punya conclusion of your analysis will represent the whole population. Sebab you nak buat inference on the population, but since there are many problems involved based on population, then you have to consider using sampling distribution. So nak guna sample tu, you have to understand dia punya criteria, okay, must be taken care of. Alright. So untuk parameter is a characteristic that describe a population. Okay. Ini adalah term-term yang sentiasa digunakan. So parameter, statistic. So what are the differences between them? Okay. So characteristic that describe a population, we call this as parameter. Tapi kalau characteristic that describe a sample, we call this as statistic. Okay. Contoh tengok mean. Okay, when we talk about, sebab untuk this chapter, this topic, not only this topic, tapi the whole STA408, memang you will meet with, you have to familiarize yourself with this term. Mean dengan standard deviation ni, for the whole topic ada. So you have to understand what is the meaning of mean and what is the meaning of a standard deviation in this course. Okay, so mean, dia punya notation yang kita guna throughout the whole chapters, topics, inilah kita guna mu. Okay, mu to represent the mean. Purata lah, okay, mean tu purata. Okay, and then sigma to represent the standard deviation. Tapi kalau sigma squared, okay, there is the power of 2 here for the sigma. So we call this as variance. Okay, variance. Okay, tapi ini mu, sigma and sigma squared ni adalah notation for the population. We call this as parameter. Ni parameter lah ni, mu, sigma, variance, ini adalah parameter for population. Okay, when we talk about sample, okay, to differentiate between the notation here, we use hat. hat ni to represent the sample. Okay. Hat ni maksudnya kita estimate, kita anggar. Okay. Okay, so normally we use mu hat or x bar to represent the mean of the sample. Okay. So untuk standard deviation we use S. Okay. Or sigma sama tapi ada hat. So hat ni sebenarnya adalah anggaran lah. Okay, nilai anggaran. Right. In order to use statistics to learn things about the population, the sample must be random. Ini another term which is random. So what is mean by random? Okay, so random ni, okay, you just imagine that there are a few, there are 100 number of students, okay, and you want to pick 5 of them randomly. Okay, so ada 100. Okay, n equal to 100. So 100 number of students. Okay, number of students here. And you want to pick 5 of them randomly. So macam mana nak pick randomly? So ni seorang, you just pick randomly. Tak tahu pun siapa, tapi dah cukup 5 orang. So here we call this as randomly selected from the group here. Okay? So a random sample is one in which every member of a population has an equal chance of being selected. Meaning that, okay, 5 orang ni, it has an equal chance to be selected. So siapa-siapa pun yang kita pilih kat sini, every one of 100 students here, ini adalah population, saya assume that this is a population. Okay, so we want to pick 5, okay. Our sample here, sample 1, we want to pick n equal to 5 from this. Okay, randomly. Bila kita sebut random, maksudnya 100 of students here has an equal chance to be selected. Okay, itu random. Tapi bila pilih-pilih tu kita tak tahulah siapa yang kita pilih. Which means that ambil. So we have 5 here. Okay, so inilah yang kita katakan randomly selected. Right? So variable means any characteristic whose value may change from object to object in a population. Tengok kat sini ya. Ni contoh, kejap. Okay, show you this. Ni population. Okay, and then here is sample. Okay, so this is the parameter here. Mean. We are talking about mean. Okay, mean. Okay, so overall here, if you compute the number of, we call this as the number of students lah. Okay, so here let's say this we have 100 and here we have 6. So sample yang kita ambil adalah 6 daripada 100. Then we pick 6 out of 100 here randomly. So randomly selected. Okay. So if you calculate the mean from the whole population here, okay, so value dia adalah mu. Dia punya notation that we use is mu. Tapi kalau if you calculate the mean based on the first sample here, so the notation that we use is x bar. Okay, which is x bar. Sometimes ada juga yang guna mu hat. Okay, samalah. Sama aja dua ni. Okay. Boleh faham ke?
Boleh.
Boleh pandai-pandai ni. Alright. Okay, example. Okay, contoh let's say we have a data of age of students, number of students and weight, gain or loss. Okay? Okay, so population ni all students over 20. Okay, all students over 20. Okay. So sample only the students in our study. Example 35 number of students over 20. Okay, kalau population ni all, and then we just pick randomly 35 number of students over 20. Okay, dia punya weight lah. Okay, over 20 kilogram. Okay, so now parameters. Okay, average weight gain or loss of all students over 20. Itu adalah parameter. Okay, untuk all students. which is ni mu lah. Okay. Average ni kan mean. Alright. So mu lah. Okay. Statistics. Average weight gain or loss of 35 students. Okay. 35 students over 20. Tambah over 20 in our study. Okay. So this is X bar lah. Kalau you compute the value, so the value represent the X bar. Okay. But here, if you compute the value, it represent the mu here. Okay. So variable apa yang kita guna sekarang ni? Weight. Okay. Over 20 kg ni dia punya weight lah. So kita ambil dia punya weight of all students. Weight of 35 students. Right. Okay. Any question here?
Ada 35 tu number student ke berat?
Sorry, tak dengar. Apa dia?
Average weight, weight 35.
Okay, 35 ni number of students yang kita collect. So let's say all students ni kita tak in this example kita tak mention how many. So let's say the total number of students is 10,000. So 10,000 ni dia punya weight is over 20 kg lah. Okay, so kita ambil lah 1, 2, 3 up to 10,000. So dia punya weight tu. Okay, so you collect dia punya weight. Tapi weight tu mesti over 20 kg. So 21, 22, 25 up to berapa lah. Right? Okay, so ni all students. And now kita nak pick 35 randomly from this. So kita ambil 35. Okay, so 35 ni number of students based on sample yang pertama yang kita collect lah. Okay, so N1 ni adalah the first sample. 35 number of students. So kita collect dia punya data dia. Data apa? Data dia adalah weight. Right? Boleh?
Boleh.
Okay. So ini definition of a random variable. So random variable is a quantitative variable whose variable is determined by the outcome of a random experiment. So it is based on experiment. Okay. So experiment ni apa? It's a process that result in different outcome when the experiment is carried out in the same manner several times. Okay. So what we mean by a random experiment ni? Ni contoh lah. Okay. Contoh, if let's say we toss a coin. Okay, ni eksperimen. We toss a coin, so you can try to toss a coin. So what happened? If you toss a coin, what happened? So the result of the experiment will either come out as tail or head, right? Kan? Kalau you toss a coin.
Betul.
Okay, so it's either head or tail. Okay, tapi kalau you toss a die, okay, so the result would be the number of in the set would be 1, 2, 3, 4, 5 and 6, right?
Doktor, dice ke die?
Die, kalau satu.
Dadu, bola dadu. Oh.
Yeah.
Satu dadu.
Alright. Okay. But if we toss a coin twice, then there are 4 possible outcomes here. Here you have to try or imagine this. Okay, you have to try to toss a coin but twice. So, what are the possible outcomes if you toss a coin twice? So cubalah baling. Okay, cuba. So what are the possible outcomes? Okay, so in this case, actually it's easier for you if you use a tree diagram to understand this. Okay, so katakanlah the first toss. The first toss, it is either head or tail. And then sebab ni you buat 2 kali twice. So you ambil lagi. Okay, ni second toss. Okay, so you get head and tail. And here also head and tail. So possible outcomes that you will have here is either head and head head and tail, tail and head, tail and tail. So this is what we mean by 4 outcomes. Okay, so ada 4 lah. Okay, 4 outcomes here. Boleh?
Boleh.
Right. If we are making both with a machine, the result of the experiment is that some may be defective. Okay, so kalau if we are talking about a product, okay, tak kisahlah both with a machine ke apa-apa jenis produk. So the result of the production can be defective and also non-defective. So in this case, we have 2 possible outcomes. Okay, even kalau you ambil exam, you also have 2 possible outcomes. It's either you, betul tak? 2 possible outcome. If I give you a test or a quiz, okay, is either you pass or you fail. So it means that we have 2 possible outcomes in this case. Okay, so it depends on the situation, it depends on the problem given to you. Sometimes the situation give you only 2 possible outcomes. Sometimes it give you 4 possible outcomes and so on. It depends on the situation lah. Okay, so if an experiment consists of measuring lifetimes, okay, ni contoh macam kita nak measure lifetimes of electric light bulbs, then the experiment is a time in hours that lies in some intervals such, let's say 0 to 3000. Okay, hours lah ni. Okay, 0 hour, okay, and then 3000 hours. Okay, dia punya lifetime. Okay, so ini dia ada range. Okay, some intervals here. Ada juga yang macam ni. Okay, ada yang dalam bentuk pass or fail, 2 possible outcomes. Okay, ada yang dalam bentuk 4 possible outcomes. So contoh, these are examples. Okay, ada example. Ni boleh tengoklah nanti you can try this nantilah, nanti dalam tutorial kita try, right? Okay, so yang ni discrete probability distribution. So kita nak masuk discrete probability distribution. Remember that I mentioned earlier, we have 2 type of distribution, which is discrete and also continuous distribution. So untuk discrete, we will only cover 2 type of distribution, which is binomial distribution and also Poisson distribution. Ada 2 je. Untuk continuous, normal distribution. So altogether ada 3 je. Cuma you have to know how to differentiate between these 3 lah. Okay, when to use binomial, when to use Poisson, or also normal distribution. So untuk discrete probability distribution, if X is a discrete random variable, okay, which takes X1, X2, ini adalah dia punya value X1, X2 up to Xn respectively with probabilities. So dia ada dia punya probability lah. Okay, probability that X equal to X1, probability that X equal to X2 and so on here. Then, okay, the probability must be bounded between 0 and 1 and the whole set of the probability values must be equal to 1. Okay, yang ni logiknya nilai probability pernah tak jumpa lebih dari 1? Tak ada Probability value memang dia bounded between 0 and 1. So this is what we mean here. Probability takkan lebih daripada 1, takkan jadi negatif. So the value must be bounded between 0 and 1. So let's say you try to solve a question and you find out that dia punya value ni 1 point something. So salah lah tu. Okay? Or negative. So itu dah bagi you the clue that you are not on the right track. Salah. Okay? So must make sure that the probability value must be bounded between 0 and 1. And then if you total up all the probability values, it must be equal to 1. Okay, probability value dia takkan jadi lebih daripada 1. Okay, everything must be 100%. Mesti 100%. Alright, kita tengok contoh. Right, example 1. So example 1. Okay, we toss 2 coins and observe the number of heads visible. So, therefore, the random variable x is, okay, tengok kat sini ya. Term yang you kena faham is sample space. So, what is meant by sample space? Okay, and then what is the variable involved? So, variable ni tentang apa yang dia nak? So, x is your variable lah. So, definition of x here is number of head. Number of head visible. So dia nak number of head visible. And then from this you will be able to find the probability. Okay, probability. So let's try to solve this. Ini adalah 2 coins, meaning that you toss 2 coins. This actually the same as we toss a coin 2 times. Sama lah sebenarnya dia punya situation here. Tapi apa yang dia nak is you have to observe the number of head. The number of head visible. Okay, so now first coin you dapat apa? You dapat apa? Dia punya outcome.
Head.
Tail.
Head.
Alright, good. Right, good. Okay, and then second coin sama, head and tail, head and tail. So here possible outcome is head and head. Head and tail, tail and head, tail and tail. So this is the possible outcomes, right? So possible outcomes ni is your sample space. Okay, sample space. Okay, so actually inilah yang kita katakan sample space, which is the possible outcomes of this experiment. Okay, which is sample space. Is called as sample space. Okay, sample space. So you list down the sample space here, which is H and H, H and T, T and H, T and T. So the number of head visible for the first outcome is 2, right? So you count the number of head. So 1, 2. So you dapat 2. Untuk second outcome, got 1. Third outcome, also 1. And the fourth outcome, you got 0 here. Okay, so this is the number of head visible. This is your variable. Variable you not head visible. Okay, and then so what is the probability of getting x? Okay, so px means that what is the probability of getting the number of head? So this means the probability of getting the number of head. Head. Okay, so here the probability of getting 2. P ni probability of getting 2. Okay, because your X here is X equal to 2. You can also write this as X equal to 2 here. Okay, and then this is 1 over 4. Kenapa 1 over 4? Remember that this possible outcome ada 4 possible outcome. Okay, 4 possible outcomes. So the total is 4. Okay, berapa kali you dapat X equal to 2 in this case? Only 1. So this is 1 over 4. Okay, so the probability of getting the number of head equal to 2 is 1 over 4. And then the probability of getting the number of head, which is X equal to 1 in this case is, okay, in this case, the number is 2 over 4. Okay, because this is 2 over 4. 1 over 4 plus 1 over 4. So you get 2 over 4, which is equal to 1 over 2 lah, half, right? Boleh? And then the probability of getting the number of head visible equal to 0 is 1 over 4. Okay? Any question here? Do I need to repeat? Do I need to repeat the last column here?
Oh,
No, it's okay.
no, it's okay.
All right.
Faham,
Okay.
faham.
All right, good. Okay, so here in this case, if you total up all the probabilities, remember this term here. Okay, total up I equal to 1 up to n, which means that you total up P x1 equal to x1 here, okay, plus P all the probability values here, okay. x2 and so on, okay, then the value must be equal to 1, okay. So total up 1 over 4 plus 1 over 2 plus 1 over 4. So you total up everything here. So the summation of the px in this case would be 1 over 4 plus 1 over 2 plus 1 over 4. So you get 1. Okay. So ini yang kita tunjukkan tadi lah. Dia punya probability values must be equal to 1. Okay. But for each of the probability here, which means that the probability of getting the number of head equal to 2 is 1 over 4, which is less than, is bounded between 0 and 1. So ini pun bounded between 0 and 1. Okay, yang ni pun bounded between 0 and 1. So this is what we mean by the first condition here. Untuk A ni, okay? Dia punya individual probability must be bounded between 0 and 1. But if you total up all the probability values, then it must be equal to 1. Okay? So ini bukti dia lah. Okay? Ini contoh yang kita boleh explain to represent the two conditions tadi. Alright? So example 2. Example 2. If you toss 3 coins. So this is for your own exercise. Okay? I leave it this example for you to solve. Okay? So next class, which is during the tutorial session, so you boleh, we can discuss the answer kat sini. Okay? So example 3. Okay, next is the mean and standard deviation of a discrete random variable. Untuk example ni kita akan discuss during the tutorial session. Boleh Tapi kalau kita ada masa, it's okay to discuss that during the lecture session. Boleh. Alright. Sebab takut tak sempat nak habis syllabus kan, then I have to be fast here. Okay, so the mean and standard deviation of a discrete random variable. So tadi contoh yang kita bagi tadi is about discrete, discrete random variable. Okay, continuous tu macam mana? Nanti continuous tu nanti next kita akan discuss on continuous lah. Okay, remember that discrete lawan dia continuous discrete. Okay, so in this case, if you are given a discrete random variable, so how to compute its mean and its standard deviation? Okay, so this is the formula. Okay, so formula to compute the mean, to compute the variance. Okay, or standard deviation of a discrete random variable. So you just use the formula. Guna formula ni je. So macam mana nak guna? Okay, let's check it out based on this example. Okay, cuba tengok yang ni. Example 4. Okay, so in this case mu population punya notation. Okay, remember this is mu, this is variance, sigma or sigma squared. So ini adalah notation to represent the population population. Okay, so the formula is x times its probability value. So if you total up this one, which means that x1 times px1 plus x2 times px2, okay, then this will give you the value of the mean. Okay, the value of the mean. And then if to calculate the variance, okay, to calculate the variance, tengok ni, you square the value of x. Okay, which means that x1 you square the value and multiply by its probability value. Then x to the power of 2, okay, x2 to the power of 2, you square the value of x and then multiply by probability x2, okay, and then minus with the mean square. Mean tu ambil kat mana? Ambil daripada yang ni. Tapi you have to square it, okay, the value of the mean. Then it gives you the value of the variance. Okay, so if you want to find the standard deviation, you square root the variance. Okay, square root the variance, then you get the standard deviation. Okay, let's refer to the example. Example. Okay. Actually, to compute the mean and the variance here, you can also use the previous example. Boleh guna example 1, example 2 and so on. Boleh juga. Okay. Tapi based on this, kita cuba tengok based on example 4. Okay, so find the expected value from the following probability distribution. So this question asks you to find the expected value. So expected value ni apa? Expected value ni adalah the other term that we can use to represent the mean. Okay, mean. Boleh guna mean, boleh panggil expected value, boleh juga guna term average. Okay, average. So sama je sebenarnya. So which is you nak kena compute the mu tu. Mu tu mean lah, alright? So mu. Okay, so remember the formula. So mu is actually summation of x multiplied by p probability value of that x. So here I equal to 1 up to n lah. Okay, so in this case, so what is your x? So here is x multiplied by the probability value, its probability value. So 0 multiplied by 2 over 5. and then plus, okay, ambil ni pula, the second x. Okay, so 1 multiplied by 8 over 15. Then plus, okay, 2 multiplied by 1 over 15. Okay, so this will give you the expected value for this probability distribution table. Kita panggil dia probability distribution table sebab ni probability probability distribution for x equal to 0, for x equal to 1, okay, for x equal to 2. Okay, total ni maksudnya total of the probability values. Remember that probability values, dia punya total must be equal to 1. Okay, tapi each of them must be bounded between 0 and 1. So 2 over 5, 8 over 15, 1 over 15 sebenarnya adalah bounded between 0 and 1 each of this value. Tapi bila total up you get 1. Okay, itu dia punya condition. Okay. Okay, condition untuk apa? Untuk discrete random variable. Okay, dia punya discrete probability distribution of a discrete random variable. Okay, so boleh dah kira dah dapat apa ni?
2/3.
Alright, so you get here 2 over 3, which is equal to 0.6667. Okay, 6667. Okay, so inilah dia punya expected value. Okay. Okay, now try to compute the variance. Okay, variance sigma squared. Okay, tak ada dalam soalan ni, but I add one more question here. Okay, find the variance of the following probability distribution table. Okay, so variance, remember that the formula of x must be squared. Okay, the power of x is 2 and multiply by its probability value. Okay, so and then ada satu lagi, jangan tertinggal ni most of the student dia tertinggal, minus with mu squared. So this is the formula. Mesti kena ada the second part here minus mu squared. Okay, so kena kira kat sini lah. Okay, so 0 squared multiplied by 2 over 5 plus 1 squared multiplied by 8 over 15. 2 squared multiplied by 1 over 15 minus with 2 over 3 squared. Okay. Cuba kira.
Zero point 356.
0.35.
5555. Banyak 5.
Okay, if we take 3 decimal places, so 356
16/45.
Okay. Okay. And then to find the standard deviation, you just square root the value of 0.356 here. So you get the sigma. Okay, sigma ni. Standard deviation. Right. Okay, next is expectation of a function of a random variable. Okay, so ini dia punya rule lah. Okay, rule to understand the expectation of a function. So if let's say we consider the x as a random variable, so a and b are constants. Constants means any number. Okay, so the first one, if you are asked to find the expected value of a, which means that expected value of 2, this will be the same as 2. Okay, expected value of a constant is actually equal to the constant itself. Okay, ini rule dia memang macam ni lah. Dia ada dia punya pembuktian tapi panjang lah kalau nak cerita. Okay, so expected value of a number, of a constant number here is actually equal to that number, right? So kalau you are asked to find the expected value of 5, so is actually equal to 5. Okay, ini untuk the first case. Okay, the second case here, kalau if you are given this kind of equation, so let's say 2a, okay, expected value of 2a, the function here is 2a, so this is the same as 2 multiplied by expected value of, sorry, mana pemadam ni, pen. Okay, expected value of 2x. Okay, so function dia x. Okay, so this is the same as 2 multiplied by expected value of x. Okay, dia macam tu. Okay, x ni function lah. Okay, it's a function. Apa sahajalah. Okay, kita tengok contoh sekejap lagi. Okay, the third case, if you are given this function, okay, it involves two type of function, gx and g2x. Okay, g1x and g2x. You can split it into two. Okay, so this is the same as, let's say, expected value of 2x plus 5x. Contoh so you can split it into two, which is this is the same as expected of 2x plus expected of 5x. Okay, which is 2x means 2 multiplied by expected value of x. 5x means 5 multiplied by expected value of x. Okay. Okay, and the last case is ax plus b, which means that a and b ni adalah constant number, which is any number. So let's say we are talking about 2x plus 5. Okay, 2x plus 5. So you can change it into this form, which is 2 multiplied by expected value of x plus 5. Sebab apa? Sebab remember that expected value of 2x is 2 multiplied by expected value of x here. And then expected value of a constant is a constant. Okay, remember that expected value of 2 is 2. So expected value of 5 is actually 5. Okay, so dia jadi gini lah. Okay, so why do you need to know this? Because if you are given this kind of question, so it will help you to solve. Okay, if you know this rule, then it will help you to solve the question easily. Okay, so contoh this kind of question. If you are given this probability distribution table, okay, which is each of the probability is bounded between 0 and 1, and the total number of probability values here. Total probability values here is equal to 1, and you are to find the expected value of x. Ni adalah mean lah. Okay, mean. Expected value of x, mean lah, right? And then this one is expected value of x squared. Okay, expected value of 4x plus 3. Dia ada function dalam dia. So without this rule, memang it's not easy to solve this question. So kena guna rule ni lah. The 4 rules that we have just discussed. Okay, so in this case, let's try to answer the question. Okay, boleh cuba. The first one, untuk mean senang je lah. Okay, you just follow the formula to find the mean. The formula is summation of x multiplied by probability values, which is x1 multiplied by dia punya probability values plus 2, second x is 2 multiplied by 3/9 Okay, then plus third x is 3 multiplied by 1/9. Then 4 multiplied by 3/9. Okay, so kira
2.556.
okay, 2.556. Right, that's correct. Right. Okay, let's go to question B, which is expected value of x squared. Okay. Okay, so to answer the second question here, you have to include the x squared in the formula. Okay, x2 adalah has the power of 2. Okay, so masukkan the power of 2 in the formula. So, dapat tak? Hmm.
7.889.
Alright, that is correct. So you get here 7.889, or in other way, you can also write this 71/9. Betul juga lah. Okay. Alright. Okay. Let's proceed to C. So C, 4x plus 3. Okay, so the function here is 4x plus 3. So you have to know how to use the rule. So which rule should you use? 1, 2, 3, 4. Mana yang related to C?
4. Nombor 4.
Right. Okay, try to solve the question. Simple je lah. Because you already know the expected value of x. So don't repeat the solution. Just refer to the A here. Okay. To the first solution here, which is 2.556 plus 3. Okay.
Belas 13.222.
Okay, so 13.22222 It depends on the decimal points that you use here. Okay, so kalau you guna 556, kalau if you consider 3 decimal points, so it should be 3.224 Okay. If you use 3 decimal points. Okay, so done. Now go to D. Okay, so D, cuba buat D.
.17.334.
Okay, 17.334. 3, 3.
4.
Alright, that is correct. Betul? Okay, how about E? So saya tak tunjuk lah dia punya solution Okay, but if you have any question, you can just contact me Okay, if you have any question. Okay, E.
Oh, variance.
Yes, E is the variance, sigma squared. Okay, variance. So remember that the formula of the variance is involve everything that you have just calculated earlier, which is you boleh ambil je from this, the point here. Remember that to calculate the variance, actually the formula is at EX squared minus EX, and then you square the value. Okay? Actually, this is the formula for the variance. Remember that this is the first part, okay? X squared multiplied by px, and then minus with the mean. So this is the mean value. And then you square the mean value.
$1.356.
1.356. Okay. Or you can also write this in a fraction, which is 110 over 81. All right. Next is to compute the variance. Okay. Ini involve variance jugalah. Okay, sikit Tapi sebenarnya there are also rules to compute the variance, which is if you are to compute the variance of a constant, so actually the value is 0. Okay, variance of a constant, variance of 5 is actually 0. Variance of 10 is also 0. As long as this is a constant value. Okay, so the value is 0. Unlike the expected value. Kalau expected value of a constant is a constant itself. Okay, so kena ingat di antara mean and variance here. Okay, expected value and the variance V. So if you are to compute the variance of AX, okay, variance of AX means variance of 2x. So this is actually equal to 2 squared. Sebab ini variance 2 squared. And then variance of x. Macam tu. So this is 4 lah. Okay, 4 times variance x. Okay. And then the last here is, let's say you are to compute the variance of 2x plus 5. So this is actually equal to 2 squared multiplied by variance x plus 0. Okay, 0. So tak ada lah kat sini. Because the variance of a constant is 0. So tak ada. Okay, so dia sama lah jadi. Okay, boleh
Boleh.
Alright. Okay, so refer to, ini kita dah calculate tadi variance. Example 5, find the variance, dah. Alright, example 7. Example 7. Okay, boleh cuba. Tak apa, yang ni you cuba sendirilah, senang je ni. Okay, cuba yang example 8. Ya. Jawapan dah ada ni. Okay, try to answer the question. Kalau ada masalah, then you boleh beritahu lah. Then I show you the solution.
Yang E tu nanti 702.
Which one?
Yang E, variance. 702 tu kan, tinggal.
So 7x kan? So dia akan jadi 7 to the power of 2 variance x. Okay? Have you finished?
Okay. Dapat.
Dapat Yang lain? Okay tak?
Okay.
Okay. Right. So you can just compare your solution. Okay, you can check your answer. So kalau tak dapat tu, then check where is your wrong step. So kena tengok kat mana salah Alright. So next is binomial distribution. Okay, so today we will cover up to binomial distribution. Okay, so binomial distribution is one of a discrete random distribution type. Okay, remember that kita sekarang ni kita nak cover discrete probability distribution. So under discrete we have two type of distribution. Okay, discrete probability distribution. Okay, so we have binomial and also Poisson. Binomial ni nama glamour dia BIN ni binomial lah. Okay, binomial. Okay, so binomial distribution, so we cover this part first. Okay, binomial. So binomial distribution ni related to Bernoulli process. Okay, macam an experiment that consists of repeated trials, each with two possible outcomes. Okay, kalau ada two possible outcomes, so ini adalah Bernoulli process, which is referred to the distribution apa? Distribution dia binomial distribution. Okay, binomial distribution. Okay, proses dia namanya Bernoulli process. Okay, anything that have any experiment lah. Okay, any experiment that has two possible outcomes. Okay, two possible outcome. It can be success or failure. It can be apa lagi It can be anything that deal with two possible outcome, head and tail. Okay, as long as ada two possible outcomes, then it can be regarded as following binomial distribution. Okay, kalau ada three possible outcome boleh tak? Can we regard that experiment to follow the process? Kalau dia ada three possible outcome. No, so anything that have two possible outcomes, then it follows binomial distribution. Okay, ingat. So bila masa soalan tu you are given many type of questions, so you kena identify this based on the possible outcome. Kalau dia ada dua je, ini binomial. So jangan guna formula Poisson pula. Okay, ni cara untuk kita identify, to differentiate when to use binomial distribution formula, when to use Poisson distribution formula. Okay, so in this case, example, testing of item as they come off an assembly line where each test or trial may indicate a defective or non-defective item. Ini macam defective and non-defective. So we have two possible outcome. Okay. So as long as we have two possible outcome, then this referred to binomial distribution. Okay, with a Bernoulli process. Okay, dia punya proses namanya Bernoulli process. Okay, so each trial is called Bernoulli trial. Okay, so other probability problem that having two outcomes. Okay, ni lah abnormal, normal, true, false, yes, no, win, lose, or gender. Ni gender female and male je lah. Jangan tambah yang lain pula. Okay, kalau female and male, then we have two possible outcomes. Okay, right. So classification of success and failure. Okay, untuk Bernoulli process, the term that we use is either success or failure. But it doesn't mean that success is good or success is good and failure is bad. It does not imply that definition. Bukan tapi proses ni, bila dia ada two possible outcome, we call the first one is success and the second one is failure. Itu adalah term yang kita guna. Okay? Remember this part. Okay? Take note on this. The classification of success and failure does not imply that one outcome is good and the other is bad. Okay? Bukan Kita tengok contoh. Alright. It's just n independent Bernoullis added up. Kalau melibatkan n independent Bernoullis, then we call this as to follow the distribution lah. Dia ada distribution lah, which is binomial distribution. Okay, so the distribution is applied to experiments that satisfy the conditions of a binomial experiment. Okay, so kita tengok the experiment, kalau experiment, the condition of a binomial experiment. Okay, kalau eksperimen tu consists of a fixed number of trials, contoh n number of trial, 10 number of trial. So this is what we mean by n independent Bernoullis here. Kalau each trial result in one of two outcomes, okay, so as long as ini dia punya four condition here are satisfied, so ini adalah binomial distribution. Okay, so one of the condition is that two outcomes, mesti ada two possible outcomes, and then the trials are independent. Maksudnya trials, sekejap kita tengok what is mean by independent here. And then the probability of success must be the same in each trial. Okay, trial yang pertama, apa probability value dia? Mesti sama dengan trial yang kedua, up to n trials. Okay, so we assume the same number of probability of success for each trial. Okay, so the probability of failure must be 1 minus P lah. Okay, P and Q dia punya P, Q ni number of probability. Okay, okay. So probability of success, P ni probability of success, Q ni probability of failure. Okay, so Q ni boleh juga compute the value by using 1 minus P, right? Ni probability of success, ni probability of failure. Alright, so ini cara tulis X ni random variable that follows this distribution, which is binomial distribution, BIN, binomial. Okay, so N ni adalah number of trials. Okay, N ni number of trials. Okay, P ni number of, probability of success. Okay, P ni probability of success. Okay, ni cara tulis dia punya distribution. Okay, so X, okay, follows. Okay, ni maksudnya X, maksudnya variable tu dia follows binomial distribution with, okay, n number of trials. Ni n ni adalah number of trials. Okay, number of trials. And then P ni adalah probability of success. Okay, probability of success. So this is P. Okay, number of trials ni is N. Right. Okay, so a trial is an action which result in one of several outcomes. So when one trial does not affect the outcome of another trial, they are said to be independent. So ini kita panggil independent. Okay, maksudnya you buat eksperimen tu, so one trial dia takkan mempengaruhi the outcome of another trial. Okay, so dia independent. Okay, kita tengok contoh. Example. When you throw a die 4 times. Okay, when you throw a die 4 times. Tak nampak pula. Okay. When you throw a die 4 times, so what happened? You record the random variable. The random variable ni apa? The number of time a 6 is obtained. Okay. So ini data yang kita nak collect adalah number of times a 6 is obtained bila you throw a die 4 times. Ni contoh So kena imagine sikit lah. Okay. So ambil dadu. Then you... Sorry, ada soalan ke? Tak clear. Tak ada kalau ada soalan, kalau I didn't notice any question, kalau you guna message ke apa, then please help me because saya guna screen ni je, so saya tak nampak. Okay, so in this example, if you want to understand the concept here, you have to imagine this, or you have to use this. Try to experiment this on your own. So you ada die, satu je dadu, then you throw the die 4 times. So 4 kali. 1, 2, 3 and 4. So the 4th, okay? And then you record the random variable. Apa random variable tu? Apa yang you nak record? Okay, depends on the question. So in this question, dia nak number of time a 6 is obtained. Okay? So berapa banyak lah kalau nak dapat ni. Okay, so each ini yang kita katakan the 4 condition untuk ni dari tadi ni ada 4 conditions of a binomial experiment. There is a fixed number of trial, which is you baling dia sebanyak 4 kali. So n equal to 4. So berapa banyak you buat eksperimen tu? So 4 kali. Satu je eksperimen tapi trial dia tu berapa banyak? So you throw a die 4 times. So n equal to 4. Okay? So n equal to 4. Okay, second, each trial has 2 outcome. Betul tak? Satu kali you throw, then you dah ada 2 outcome je. Sebab apa? Sebab apa 2 outcome? Kenapa bukan 6? Tadi kan bila kita discuss on a die, kita ada 6 because 1, 2, 3, 4, 5, 6. But in this case, kita bukan nak tengok benda tu. Kita punya variable yang kita nak tengok adalah number of times a 6 is obtained. Kita nak dapat 6 tu. Okay? So each trial has 2 outcome. It's either you dapat number 6 ni ataupun tidak. Faham Can you understand this?
Yes.
Okay. So kalau you dapat number 6 tu, bila you baling, you dapat nombor 6 tu, itu adalah success. Kalau you dapat selain daripada 6, itu adalah failure. Yang 1, 2, 3, 4, 5 tu adalah failure. Okay? Sebab apa? Sebab ini yang kita nak adalah ini. Depends on the question. Okay? Sebab variable you, x you adalah the number of times a 6 is obtained. Right? Okay. So the trials are independent. Which means that the result of a throw does not affect the outcome of the next throw. Maksudnya you buat satu kali, dia tak mempengaruhi pun you nak buat yang kedua, yang ketiga. Result dia tu. Dia independent. Kalau dia dependent maksudnya kena dapat ni. Tak ada, bukan macam tu. Okay, untuk binomial experiment ni dia independent trial dia. Alright. So the probability of getting a 6 is the same for all the throws. Okay? Probability of getting a 6. Throw yang pertama ke, second throw ke, third ke, fourth ke, you akan dapat probability yang sama. So ini adalah condition dia. So 4 ni adalah condition syarat-syarat untuk binomial experiment. Dia tak ada case yang probability yang pertama dapat 1/6. Probability yang kedua dapat 2/6. Tak ada. Tak ada case macam tu untuk binomial. Right? Okay. Ini example 1. So by right, you boleh tulislah X follows binomial distribution n equal to 4 and probability of success is 1/6. So based on P equal to 1/6. So by right, you should know that dia punya Q is 5/6. Okay, di sebaliknya lah because P plus Q equal to 1. P plus Q equal to 1. Remember that the number of probability values probability values kan equal to 1. So success plus failure equal to 1. Right. So ni cara kita tulis. Okay, example 2. Suppose a multiple choice quiz has 20 questions. Okay. A multiple choice quiz has 20 questions. Okay, and each question has 4 possible answers. Bilik saya ni ada bunyi tak? Ada bunyi benda ni tak? Aircon ni rosak. Mengganggu tak?
Tak sangat. Boleh je.
Ganggu, boleh je.
Boleh je.
Bunyi apa dia punya air tu tapping. Alright, so example 2, suppose that a multiple choice question has 20 questions and each question has 4 possible answers. Maksudnya A, B, C, D lah. Okay, satu soalan ada A, B, C, D. Soalan kedua A, B, C, D. This is what is meant by this. Okay, and then let X, okay, random variable ni, number of correct answers obtained by a student who answer all the 20 questions. Okay, so kita nak tengok berapa banyak jawapan yang betul. Okay, so trial dia berapa banyak? Okay, based on this, you should know that the number of trial is 20. Okay, there is a fixed number of trial which is 20. So soalan tu lah, jumlah soalan lah, 20 soalan. So trial dia adalah 20. So each trial has 2 outcome which is correct and not correct. Okay, getting a correct answer is a success. Getting a wrong answer is a failure. Okay, so kita ada 2 outcomes. 2 outcomes here. Okay, correct and wrong. So the trials are independent. Okay, which means that the result of a question does not affect the result of the other question. Okay, and then the probability of getting a correct answer in each question is the same. Okay, soalan pertama, probability untuk dapat jawapan betul adalah 1/4. Soalan kedua pun sama, 1/4. So ini yang kita katakan the probability of success must be the same in each trial. Okay, in each trial. Okay, so this is what we mean by that sentence. Alright. So to write this properly, we can write it as X follows binomial. Okay, with 20 trials. Okay, 20 number of trials and 1/4 probability of success. So kalau probability of success dia 1/4, so probability of failure adalah 3/4 lah. Okay. Okay, next. This is the formula to calculate the probability. Okay. If, okay, you are asked to compute the probability of X success in N trial. Maksudnya kalau you kena compute dia punya probability. Okay, contoh, baca dulu yang ni. So discrete random variable X represent the number of success in N trial of a binomial experiment is called a binomial random variable. Okay, so X tu kita panggil binomial random variable sebab kita tulis macam ni, X follows binomial N and P. So X ni adalah represent the number of success in N number of trial of a binomial experiment. So kita panggil dia sebagai binomial random variable sebab X ni follow binomial. Okay, so X follows a binomial distribution. So ni kita tulis notation yang kita boleh tulis lah. Okay. Alright. So the probability of X successes in N number of trial is given by this formula. So formula ni boleh guna calculator je sebenarnya. Boleh guna calculator. Contohnya, if you are asked to compute the probability that X equal to a certain value of X. So ini formula dia. Kena guna, okay, if you refer to your calculator, you tengok, saya tak tahu, I do not know what type of calculator did you use. Tapi kalau you guna scientific calculator, kalau saya ni saya guna yang lama punya ni. So you tengok je NCR, ada tak? NCR in your calculator.
Ada.
Ada nampak tak color dia apa?
Guna kat bahagi kan.
Betul.
Bahagi kat bahagi.
Ini bahagi kan. Macam tu kan. Ini division punya button, lepas tu ada NCR kan? NCR.
Betul.
Alright.
Kena shift.
Betul. Kena shift sebab dia punya color tu yellow color So kita guna shift and then you kena guna shift then only you katakanlah you nak dapatkan saya bagi sekejap lagi lah kita tengok contoh Okay. Ini je tengok formula dulu. So NCX multiply by probability of x to the power of x and q to the power of n minus x. Ini formula. So formula. So nak guna formula ni pun boleh, nak guna the second part here pun boleh. Okay. So actually the idea is that NCX ni this part ni sebenarnya macam ni formula dia. So kalau ingat lagi add math masa sekolah dulu, ni lah n factorial. N ni maksudnya n factorial divided by x factorial multiply by n minus x factorial. So dekat sini, ni x, ni n minus x. So factorial. Kalau tak nak guna yang ni, boleh guna formula ni. Ini probability of success tadi to the power of x. Ini probability of failure to the power of n minus x. Itulah konsep dekat sini. Okay. Other than this, ini guna calculator So nak calculate benda ni boleh guna calculator or ada dua cara calculator or statistical table. Boleh using cumulative binomial property. Ni table boleh guna statistical table. So ada dua cara boleh guna. You nak guna calculator pun boleh, you nak guna statistical table pun boleh. Tapi statistical table ada dia punya cara-cara dia. Right? Okay. You have to know how to use the table. Alright. Okay. So kita pergi pada contoh. But before that, one more things that you need to know is to compute the mean and the standard deviation of a binomial distribution. So ni formula dia lain Untuk binomial distribution, remember that variable dia kita tulis dia x follows binomial with n number of trial and probability of success, p probability of success. So to compute the mean of this distribution, okay, mean of this binomial distribution, you have to follow this formula. Okay, so formula ni ada dalam list of formula sebenarnya. Okay, cuba you check lah dalam list of formula yang saya bagi tu. So sebenarnya kalau dah ada dalam list of formula, you tak payah hafal pun. Okay, kalau ada, kalau tak ada kena tengok lah. Alright, so formula dia sangat senang So to compute the mean, so formula dia is n times p. So ambil ni je, n times p. Okay, and then to compute the variance, so formula dia adalah n times p, n times q. Okay, and then standard deviation, you just square root n times p times q, square root the value. Okay, so formula ni tak susah pun sebenarnya senang je sebab ambil je dari sini n times p times q. Tu je. Okay, tengok example. Example 9. Alright. So the probability, cuba baca soalan dulu Baca soalan dulu. Try to understand the problem first. Okay, I need to show you the calculation. Okay, so let's try to answer the question. So the probability Okay, so the probability that a patient recovers from a rare flu disease is 0.4. Maksudnya probability yang patient tu recover, recover. Probability. So you, bila you baca soalan, you have to jot down a very important, find the point, very important point from the question. Okay, so okay, so probability that a patient recovers from a rare flu disease. So maksudnya apa 0.4 tu?
Success.
Probability of a success. So P probability So ini adalah P probability of success. So apa dia punya variable dia in this case? So what is the variable?
No.
Survive or not survive?
The number of patient that survive from this disease. Okay, so the number of patient that survive from this disease. Okay, so in this case, X follows binomial distribution. Dia jadi tak ni pula. Tak best lah guna ni. Problem pula. Tak boleh. Sometimes dia okay, sometimes dia tak okay. So saya tak boleh guna yang ni. Saya contohin je lah kat sini. Okay, so X here follows binomial distribution. Okay, so n number of number of trials. So trial dia berapa?
20.
Okay, so 20 people. Okay, 20 people. So n number of, okay, 20 number of people. Okay, 0.4 probability of success. Okay, so probability of success here is patient recovers from rare flu disease. Okay, so that is your X. So X, kalau you nak, if you want to understand it, then you have to define the X. So X represent the number of patients recovers from the number of patients. Okay, patient recovered. Okay, the number of patient recovered. Okay, from the flu disease. So that is your X. Okay, so the question is, okay, what is the probability that exactly 5 survive? Okay, recovered ni maksudnya survive lah. Okay, survive. Okay. So soalan dia nak probability X ni, the number of patient yang survive, okay, exactly, which is equal to 5. Okay, itu soalan A. Okay, question, the probability that is asked based on A. Okay, the probability that exactly 5 survive. So meaning that the number of patients survive equal to 5. Okay, untuk kita tulis je dulu dia punya cara nak tulis probability. Sebab kalau you wrongly write the probability that is asked by the question, so your calculation here will be wrong. Okay, so kalau exactly, so you have to use the equality sign here. Okay, okay. B, probability that at least 3 survive. So survive adalah X here. So berapa banyak? At least. So at least. Okay, ini penting information yang penting. At least 3 survive. Yang tadi exactly 5 survive. So kalau at least, the notation that we use, the equality here is greater or equal. Ni at least At least kena guna term ni lah. 3. Okay, boleh?
Boleh.
Boleh.
Okay. Next, the property that from 3 to 8. Kan kita from 3 to 8. Okay, kalau from 3 to 8, so it means that it includes 3 and also 8. So, cara kita nak tulis adalah probability that to 8. Okay, meaning that survive, the number of patients survive adalah 3 sehingga 8. So what is the probability of that situation? Okay, so we want to find the probability that the number of patients survives is from 3 to 8. Okay, so ni cara nak tulis dia. Okay, sebab bila guna perkataan from, so it means that it includes 3 and also includes 8. Okay, kalau from. So kena faham daripada soalan betul-betul should we use the equality sign or not? So it depends on the question. Okay, so D, the probability that at most 3 do not survive. Ini special case sebab soalan yang diberikan, okay, the information given to you based on the question is for survive, but the question asks you do not survive. Okay, so you have to take note on this. If this type of question is asked, so you have to change the number of, you have to change the random variable here, because we are no longer talking about X, we are talking about the other variable, let's say Y. So Y represent the number of patients that are not survive. Okay, yang tak survive okay, not survive, so Y lah kita guna. So in this case, the probability that at most, so at most pun kena tahu juga, at most 3. So at most macam mana nak guna dia punya notation? So at most is the opposite side of at least. So at most dia akan jadi macam ni.
Less than.
Less or equal. Okay, less or equal. Okay, so we no longer use X here, we use Y because of the definition of the random variable here is no longer survive but do not survive. Ni contoh lah, okay, we can use this. Ada banyak cara but this is one of the way. Okay, ni kita cara nak tulis dulu, tak solve lagi ni, alright. So yang the last one, the expected number of survivors. So expected number of survivors, which means that survivors means represent X, not Y. So this is to find the expected value of X lah. Okay, and then the standard deviation, okay, which is mean. Ni soalan untuk E, dia tanya you nak compute the mean and also standard deviation. Ini soalan dia lah. Okay, so now to answer this question, untuk A, the probability that exactly 5 survive. Okay, exactly 5 survive maksudnya equality sign here. So kalau equality sign, you boleh guna calculator, you boleh guna table, statistical table. So saya ajar guna calculator dulu untuk A ni. So untuk guna calculator, okay, refer to the formula. Okay, refer to the formula again. So ini formula dia. Okay, ni equality. Sebab tu you boleh guna calculator. Okay, sebab dia equality. Px equal to a certain number. Okay, given number of x here. So in this case, you nak cari Px equal to 5. Okay, so you boleh guna this formula Okay, NCX, which means, okay, so kita refer to the question again. So in this case, you boleh guna N, which is 20. Okay, C, X. So X, the value is 5. Okay, daripada mana? Ni lah, daripada soalan ni. So, okay. Saya tulis balik formula. So the formula is, if you are to compute X equal to X, so NC X, okay, and then multiply by P to the power of X and multiply by Q to the power of N minus X. So ini formula dia. So nak guna formula ni, N is 20, so X is 5, ni small x. X yang besar ni apa? X yang besar ni adalah random variable. Okay, random variable. Okay, X yang kecil tu value yang ditanya dalam soalan lah. Okay, a specific value given to you based on the question. Okay, so here P. P ni probability of success. Probability of success. So the value is 0.4. So ambil lah dia punya value 0.4 to the power of, okay, berapa power dia? Power dia kena tengok nilai X sebab ni power of X. So tengok kat bawah ni. So the power is 5. And then here the probability of failure. So failure is 0.6 and dia punya power is, okay, nak senang ingat, you tolak je 20 minus 5. So 20 minus 5 is 15. Okay. Okay. So yang ni ambil je direct 5 and then ini adalah 20 minus 5. So 15. So gunalah calculator. Berapa nilai dia? Okay, 0.075. Betul. So the value is 0.075. Okay. So kalau tak biasa guna lagi yang ni, so nak guna tu you kena type dulu 20. You have to type 20 and then shift and then go to the NCR tu, click that button and then dia akan appear C tu in your calculator. Okay, on the screen tu. Then you type 5. Enter, then you dapatlah nilai dia. Okay, so 20C5 alone you get 15,504 dia punya value. And then multiply by this part and the third part here, then you get 0.075. Okay? Okay, so ini kalau you guna calculator. Untuk guna calculator, you have to use this formula, which is equality constraint. Which this formula only applicable for equality constraint. Maksudnya kalau soalan A, yes, you can use the formula. But for B, you cannot use the formula. Okay? Why? Because the constraint here is greater or equality. Dia tak sama dengan the first constraint ni. So, jangan guna calculator pula nak solve yang the second one. The second one ni tak boleh guna calculator. Kalau guna untuk macam ni, salah ingat tu. Okay? Take note on this. Nak guna calculator only for this formula, which is equality constraint. You can use calculator for this. Okay, untuk yang greater or equality constraint, you can use statistical table. Okay, statistical table. Okay, so I show you how to use the statistical table. So, kena refer statistical table je. Statistical table. This one statistical table. Can you see the screen? Boleh
Boleh tengok. Boleh.
Statistical table ni penting sangat. Actually kalau you Google, you can find a few types of statistical table. Dia ada macam-macam jenis. Tapi sebenarnya you don't have to refer to other type. You just refer to the one that I shared with you. Sebab apa? Sebab bila final exam, you akan refer to the same statistical table juga. Sama je. Okay, so, tapi kalau you refer to the other type of statistical table, you akan jadi confused sikit. Value dia sama je, tapi boleh menyebabkan you confused. Alright, so untuk yang ni, table 1 cumulative binomial probabilities. So nama dia cumulative binomial probabilities. So you are using the first table for the second question ni, untuk B. So ini boleh baca lah. Okay, apa dia punya explanation here. Okay, so ini boleh tengok. Okay, P probability of success. Dia definition again. So this is the formula to compute X equal to X. Ini formula yang guna calculator tadi yang kita guna. Okay. Untuk guna statistical table ni, the table, baca ni. The table give the probability of obtaining R or more successes. Ni dia guna R lah. R ni sama dengan X je. Okay, sama je. Okay, so dia kata probability of obtaining R or more tu maksud dia macam ni. X greater than R. So small r ni sebenarnya sama dengan small x. Okay, R ni sama dengan X, small x. Okay. Dalam statistical table dia punya term dia guna R. So sebenarnya sama dengan X. So X ni a specific value yang kita nak dapatkan lah. Alright. So maksudnya table ni hanya boleh digunakan sekiranya the constraint is greater or equal. Ya, kena ingat ini je. Kalau macam ni tak boleh, salah. Kalau macam ni pun tak boleh. Macam ni ke tak boleh. Cannot use. You have to make sure that the question can be converted to this constraint. Then only you can use the statistical table here. Okay? See greater or equality constraint. Okay, so macam soalan yang the second question tadi, remember that the question is X follows binomial with 20 and 0.4. So the question is X greater or equal to 3, ya? 3. So kita nak cari mana satu jawapan dia. Okay. So ni N, number of trial. Ni P, probability of success. So kita tengoklah 0.4. Mana 0.4? Ni tak ada. Okay, tengok. Dia banyak dia punya ni. 0.4. This one. Okay, 0.4. So kat sini. And then P is 0.4 and then N20. So mana N20? Saya tengok. Ada tak? 0.4 N20. Ni. 0.4 N20. Okay. And then X is 3. At least 3 tadi ya. Ni ya. Boleh balik soalan. X equal to 3. So kita nak value of R ni equal to 3. Saya kena carilah mana satu 3. Kat sini ya. Ni. Okay, so mana satu jawapan dia? Mata saya dah berpindah ni. Nampak tak? 0. This one Betul tak? You nampak ke tak?
Betul.
Betul 0.9964
Betul.
So this is the answer. So inilah sebenarnya the probability value yang kita dapat. Okay, so let's get back to the notes again. Okay, so in this case the value is 0.9964. So it means that probability at least 3 survive. Okay, 3 patients survive from this flu disease is 99.6%. So tinggi lah probability nak survive tu. So penyakit ni taklah bahaya sangat lah. Kalau kita tengok kat sini, right. So the probability that from 3 to 8 survive. So in this case 3 to 8. So kalau soalan macam ni, kena buat sesuatu. Because macam mana nak guna? If you want to use calculator, tak boleh. Because nak guna calculator syarat dia mesti equality constraint. Remember this? Tapi if you want to use table, you have to make sure that dia punya constraint must be greater or equality. Nak kena macam ni. So you have to do something here. Meaning that you have to transform the situation here so that you manipulate the situation here so that you can use the greater or equality constraint. Tapi during the process, it still means that probability x equal to x is between 3 and 8 jugalah. Okay? Maksudnya dia masih lagi menjawab soalan. Cuma you have to do something here to make sure that you be able to use statistical table. So ini yang tricky-nya dekat macam ni lah, dekat part-part macam ni lah. Okay, so I show you how to do this. Okay, contohnya. Remember that yang kita nak adalah 3 to 8. So it means that probability yang kita nak adalah x equal to 3, okay, plus x equal to 4, plus up banyak sampailah x equal to 8. Ini sebenarnya benda yang you nak for this question. Which means that kalau you nak guna formula boleh, tapi you kena pecah satu-satu. Which means that you have to find out each of these. Probability that x equal to 3 dah dapat jawapan, plus probability that x equal to 4, plus up to p probability that x equal to 8. Panjang lah kan? Betul tak? Okay, so kalau melibatkan 3 benda je, okey lah nak guna calculator. Tapi kalau sampai daripada 3 sampai 8 ni penat juga. So in this case, you have two ways. Kalau you pecah macam ni, then you can use calculator. But it will consume a lot of your time, and the possibility to get wrong figures pun boleh jadi tinggi sebab bila you kira tu adalah silap-silap sikit. Okay, so you can also use statistical table if you can convert the situation to greater or equality constraint. So macam nak convert ni? So ini kena faham konsep. Kalau saya buat macam ni, P x greater or equal to 3, okay, minus with P x equal or greater or equal to 9. Boleh tak? Sama tak benda ni?
Dah buka 8.
Kenapa bukan 8? Remember that kita nak 3 sampai 8. So kita kenalah tolak 9 ke atas. Faham tak?
Oh, okay. Faham.
Macam tu. Kena faham. Kalau you guna 8, salah lah jawapan tu. Because remember that 3 hingga 8 yang kita nak. 3, 4, 5 to 8. So you must retain 3 up to 8. So macam mana nak guna? Probability that x equal or greater than 3 ni, dapat semua jawapan mesti kena tolak dengan 9. Yang 9 punya. Okay? Jangan tolak yang 8 punya. Kalau you masih tak ni, you kena buat garis nombor. Okay, contoh macam ni. Ni 3, 4, 5, 6, 9 and so on here. Okay, yang you nak adalah yang ni. Yang you nak adalah 3, 4, 5, 6, 7, 8. Ini yang you nak. So yang you tak nak adalah yang the rest. Okay. Yang kita tak nak. So maksudnya probability yang greater or equal to 3, you akan dapat semua ni. Semua. Sampai habis lah. Sampai n equal to 20 tu. Okay, now you kena tolak yang 9. Tolak yang ni. So the rest you akan dapat lah yang ni. Okay. Sebab you nak sampai 8 je. You nak sampai apa? Ni je. 9 tak nak. Kalau you tolak 8, 8 ni dah tak termasuk. Sedangkan you nak yang x equal to 8 in this question. Okay?
Faham.
So kalau rasa confused lagi, you tengok balik. Okay? Buat balik garis nombor ni and then you try to jot down number yang kita nak. So yang kita nak is 3, 4, 5, 6, 7 dan 8. Okay, so probability value yang greater or equal to 3 ni maksudnya involve 3 up to sampai habis. Kita nak separuh je, sikit je, kita bukan nak sampai habis. So kita kena tolak. So apa yang kita kena tolak is 9 yang ke atas. Okay, alright. So every time you have this kind of question, it's better if you can list down the number of x yang you nak dulu. Baru you tak confuse lah. Kalau dah terror dah okey, tak apalah. Okay, supaya you tak tersilap sebab most of the time student memang akan silap kat sini. Okay, silap kat sini, rugi lah. Alright, so bila dah tahu dah, then only you can use statistical table. So find out for px greater or equal to 3, dapat jawapan minus with px equal to greater or equal to 9. So that's the answer lah. Okay, jom kita tengok statistical table. So actually banyak cara sebenarnya. So ini adalah salah satu lah. Okay, kejap. Okay, kejap. Saya tunjukkan kat sini. Okay, so the question, hallelujah. Okay, so the question is x. Sorry. Tak okey juga. Sebelum ni okey je. Tak boleh. Dia problem tak? Sorry. Kejap ya. Sometimes dia tak stable. Kalau apa ni tak boleh guna. Okey, saya padam kejap. Tak terpadam pula. Dia tak. Dia conteng kat sini. Okay, so untuk soalan tadi the question is macam ni kan. This is the same as x equal to 3 plus px equal to 4 plus sampailah px equal to 8. Okay, which is the same as, kalau you nak guna, you manipulate this, then it is the same as px greater or equal to 3 minus with px greater or equal to 9. Okay, so kalau you guna cara ni pun betul, cara ni pun betul. Tapi ini guna table and the first one ni guna calculator. Or this is also the same if you use this 1 minus px. Tak boleh. Tapi tak apa, sebenarnya dia sama juga kalau you nak guna kaedah ni lah, tapi tak boleh guna table. Tapi tak boleh guna table sebab ini constraint dia ni. So tak boleh guna formula ini. Tapi persamaan tu betul. Okay, if you want to use this, betul. Tapi nak guna table tak boleh sebab ini constraint dia grade lower or equal, tak boleh. Right? Okay, so in this case, so kalau you guna statistical table, dapatkan jawapan. Sekejap, kita guna statistical table. Dapat apa? Tengok tak statistical table? Okay, so the value is 0.9964 minus with, okay, px greater or equal to 3 minus px equal to 9. So ini 0.9964 minus with, kena cari yang ni pula, 9. This one, right? Betul tak?
0.4044.
4044. Okay, so the answer would be 0. Kira
0.592.
0.592. Okay, 592. Okay, so this is the answer for C. Okay, untuk C. Okay, let's proceed to the next. Larat lagi kan ni?
Boleh.
Okay.
Aduh.
Madam, untuk less than or SM tak ada table dia. Madam.
Tak ada. Table tu, if you refer to the to the definition of the table yang saya explain tadi, dia hanya untuk greater, more tadi tu. You more, tengok kalau you lupa lah kan, kalau you lupa lah apa macam mana nak tengok, you refer back to the top of this table ni. Kan dia kata ni, the table give the probability of obtaining R or more. Maksudnya untuk ni je. Maksudnya value dalam ni hanya bagi you probability untuk case yang ni je. Okay. Kalau kurang daripada lower or equal tak boleh. Maksudnya you kena manipulate benda tu dulu. Boleh, kalau you boleh transform the situation into greater or equality constraint, then only you boleh guna table. Sebab itu syarat dia, sebab ini ni. Okay. Alright. Okay, yang ni pula D. The probability that at most 3 do not survive. So bila Y, you kena tukar dia punya variable kepada Y. Okay. Kena tukar dia punya variable kepada Y. Which means Y follows binomial distribution. Okay. Trial dia sama. 20 trial, 20 number of trials. Okay, probability of success for Y. You remember that ini 0.4 ni success untuk X. Okay, failure untuk X adalah 0.6, which is dia terbalik lah. So here is 0.6. Sebab Y ni adalah do not survive. So probability yang do not survive adalah 0.6. Boleh faham?
Faham.
Kita kena buat magic sikit, kena tukar-tukar sikit. Because the question ask you untuk case yang do not survive. Okay?
Boleh.
Alright. So in this case, you have to refer to the information based on Y lah. Okay? So tapi ini lower kan, lower than 3. So kalau lower than 3, which means that you nak guna, you have to define what is meant by lower or equal to 3. So it means that P y equal to 0 plus P y equal to 1 plus P y equal to 2 plus P y equal to 3. Ingat kalau probability dia mesti start with 0 punya value. Kalau lower tu maksudnya termasuk 0 lah. Okay. Jangan start dengan 1 je. Okay. So kalau nak guna calculator, you have to use this. Maksudnya kena calculate one by one. Okay. Untuk y equal to 0 berapa, y equal to 1 berapa, and then you total up all those, then you dapatlah value dia. Okay. Tapi penat jugalah ada 4 benda kena compute kan. Okay. So can we use table here? Can we use statistical table? Boleh tak convert?
Boleh.
Boleh. Macam mana nak buat?
1 minus
Okay.
more than 4.
Alright. More than 4. Pandai. Faham dah tu? Alright. So barulah you dah dapat. So boleh dapatkan value untuk y greater or equal to 4. Tapi kena tengoklah y tadi. Y tadi adalah binomial with 20 and 0.6. So kena refer to 0.6. Okay, statistical table dapat tak? The answer is 0.00005. Cuba kira, dapat tak? tak 0.6 in the table? Statistical table tu.
Ada.
P-value. Okay. If you refer to statistical table, okay, macam mana nak tengok P tu? Okay, sekarang dia punya P tu adalah ni lah sebenarnya sebab success you adalah 0.6. So 0.6, you kena tengok 0.6 ada tak dalam ni? If I'm not mistaken, the highest is 0.5.
0.6 dia Poisson.
Tak boleh lah. You jangan refer to Poisson sebab ini case dia binomial. So tak boleh.
Tak boleh.
So in this case, dia special, dia tak boleh guna cara guna Y tu. So that's what saya kata, dia depends on the situation, the information given to you. Kalau certain situation you boleh guna kaedah ni, kalau certain situation you tak boleh guna kaedah ni. So in this case, kalau dia kata kalau tak boleh guna Y, maksudnya okay, it's okay, tak payah guna Y. Still guna X tapi you kena tukar situation ni. Okay, contoh saya bagi you, the probability that at most 3 do not survive. Apa maksud kebarangkalian yang sebanyak-banyaknya 3 tu tak survive?
X more than 28. Equal lah. 28 lah.
Okay,
Berapa tadi?
17.
18 lah.
17.
18 orang lah.
kan?
18
Kalau
18 orang survive lah.
bukan 18, 17. So ini dah at least 17. At least
17.
you kena terbalikkan, you kena negatifkan situasi ni, you kena terbalikkan situasi ni. So this means that at least 17 survive. Kalau at most 3 do not survive, this is equivalent to at least 17 survive. Faham tak? Ni at most, so dia akan jadi at least. Ni 3, so kalau at least 17 survive. So dia opposite side of this lah. Tapi bermaksud benda yang sama. Okay? So sebenarnya boleh tukar situasi soalan ni kepada the probability that at least 17 survive. Macam tu. So, barulah you boleh solve question ni gunakan X. Okay? Sebab you dah tukar kepada X punya situation. Maksudnya you tukar kepada do not survive ni, you tukar kepada survive. So, in this case, barulah you tulis balik X which is greater or equal to 17. Macam tu. Then only you can solve the question. Okay? So, solve question macam biasalah. So, in this case, if you refer to statistical table, you dapatlah value dia. Alright. So the answer is 0. Apa? Tadi saya tulis lah.
8439.
Berapa? 0.00005 Okay. So check your answer, nanti you check. Kita akan discuss lagi next class lah. Okay, dah terlalu lama dah ni. Alright. Yang E tu you boleh compute, then we discuss next class during the tutorial session. So untuk lecture hari ni, sebenarnya kita kena habis sehingga binomial. So Poisson tu untuk lecture yang kedua lah. Okay, so which means that we have actually covered everything from discrete distribution up to binomial distribution. Okay, so kalau you refer to scheme of work, kita dah cover lah everything. Cuma exercise tu adalah untuk you familiarize yourself with problems. Okay, solving problem solvings. Okay, so yang lain-lain tu kita boleh discuss. Untuk example we can discuss during the tutorial session, right? Okay, any question before we end the session? Untuk first class ni kita try dulu. So kalau ada isu dengan duration of the lecture session, it's okay, you can just discuss. Contohnya tak boleh terima dah lebih daripada had dah. We can discuss this. We can slow talk. Okay? So boleh WhatsApp saya pun boleh guna Telegram pun boleh. Does not matter. Okay?
Okay.
Alright. Thank you. Thank you everyone.
Thank you. Thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank you.
Alright.